But some things are so reactive that as soon as they come into contact with air, they burst into flames. And I have two things here. Now, the first one is something that Chris has prepared. It's a piece of filter paper, but we've coated it with phosphorus. And phosphorus is a very reactive element, so reactive that as soon as it comes into contact with air, it sets fire to itself. Well, at least that's the theory, and I hope it does. Right, now at the moment, because we can't have the white phosphorus in contact with air, we've filled this container here with a different gas called argon. Argon is incredibly unreactive. It doesn't react with anything at all, absolutely nothing. So the phosphorus is safe at the moment, but as soon as it comes into contact with the air, it should catch fire. So when I take the filter paper out and hold it up, hopefully you'll see a reaction. If we can just have the lights down just a little bit, please. Thank you. Oops. There we are. So as soon as it came into contact with the air, it burst into flames. Good. So that was phosphorus reacting with air. And here's the chemical equation for this. We have phosphorus combining with the oxygen from the air to form, well, there are various phosphorus oxides that can be formed here, but again, releasing energy in the form of light and heat. Okay, well, we have here another substance that's very, very reactive. Thank you. And this compound contains a metal. It contains lithium metal, and this should give it a flame, a red color. And it also contains something, well, as soon as it comes into contact with any moisture, it forms methane, and methane is very flammable as well. So this should start all by itself as soon as I take the top off of this. Again, it's stored under argon. Okay, so there we are. The red color that you saw there was from the lithium that was present. And say the substance reacts with any moisture in the air to form methane. Methane is another hydrocarbon, contains 1 atom of carbon, 4 atoms of hydrogen, and it is flammable. Methane is the gas that we'd normally use most of the time for our cooking. It's the gas that's present in normal natural gas. So I have a handful of gas here, and I hasten to add I am wearing fireproof clothing and should be able to just light this. There we are. So that was methane burning in air, but I needed to supply a light in order to do that. We can see the chemical equation for this. Methane has the chemical formula CH4, and this is combining with oxygen to form carbon dioxide and water and releasing energy. Now, methane, say, is made up of carbon and hydrogen. In the same group of the periodic table as carbon is the element silicon. And silicon has rather different properties. We have the gas silane, which has 1 atom of silicon combined with the 4 atom of hydrogens. This gas is more reactive than the methane that you saw. As soon as this gas comes into contact with air, well, the methane we needed to light, this gas spontaneously catches fire. So I'm going to add some acid to the container here. In the bottom we have a funnel with a compound called magnesium silicide, and as soon as it comes into contact with acid, we get a gas called silane, SiH4. And any second now we should see some bubbles forming. And the bubbles, when they come into contact with the air, I hope, should catch fire, all by themselves. That's it. So this is silane gas. So it's, we should get a few more bubbles coming up, and a few more, there we are, a few more flashes. That's it. Silane, SiH4, so this is silicon now in place of carbon. This gas reacts with oxygen to form water and SiO2, silicon dioxide. So this will carry on, we'll hear some crackles from this throughout the rest of the lecture as these gas bubbles come to the surface.